Okay, I'm gonna go ahead and try to do this one over here. And this could be expanded all the way out too, right? But I'm going to go ahead and just substitute in here -1 minus 2, 2 times -1, oops, minus 3, plus -1 squared, minus 3 times -1, minus 1. So I'm getting here -3 times, that's going to be negative, is that 2 times? Yeah, 2 times -1 minus 3. So that's going to be -3 times -5. So that's going to be 15, isn't it? -3 times -5. And this one here is going to be 1 plus 3. 1 plus 3, which is 4 minus 1, or 3. So that's going to be 18. Is that right? That's what you got? So for our, what we'd have here, our tangent line would be y minus -9 equals 18. And we'll have x plus 1. Does that look about right? Another thing you can do is you can expand this out and then work it out that way. Did anybody get something different than I did on this? You got the same thing I did? Gavin, did you get what I got on this? Okay, all right. Okay, so we'll call, anybody check on the calculator? I guess one thing you can do is you could check this thing, right?
I don't trust the calculator.
You don't trust the calculator?
Because they gave me 16 for 26.
Oh, okay, yeah,
Like, I'm
yeah.
checking it, it's telling me I'm wrong, but I'm right. So I'll trust it.
You don't trust anybody. You're going to go back to the Stone Age before calculators. All right, that's probably, you know. So if we go to Math 8 and ddx, we're going to put here, what did we say it was? X, was it x minus something? Forget what it is. X minus 2, x squared minus 3x minus 1. X minus 2 oops. Let's do it this way. No. X minus 2 x squared minus 3x minus 1, is that what it was? And we're going to plug in -1 for that. I think I know I wrote another parentheses here. Plug in -1. Man, we should get 18, I hope. Yeah, 18.
Why does it always have like a decimal?
What it is, on the calculator, on the TI calculators, for some reason that, and it carries over to the TI Inspire too, there's some kind of a weird algorithm they have that estimates. And so what they do is an estimate of it by going back and forth with several iterations. And sometimes it doesn't get down to the bare. Here, in this case, I think that's going to be, is that 100,000th off or a millionth off? I think it's 100,000th. Is that right?
That might be a million. I think it's a million. It's a million.
Is it a millionth? Yeah, it is. It is a millionth. Yeah, you're right. 1 times 10 to the -6. You're right. So that's a millionth off. And so sometimes you'll see times 10 to the -12th, which is trillionths off. But it's just in the algorithm, the way they design the calculator. And that's probably the most efficient way they could do it. And that's one thing that is a concern to the designers of the successive operating systems. And there is a new operating system to this thing that I don't know if it's worked out, but it's the same type of problem for TI Inspire too. It's just endemic to the brand. And it doesn't mean it's not a good calculator. It means that, hey, it has its limitations.
Still has a margin of error.
A margin of error, and you have to realize that what you're looking at is 18. Okay. Yeah, so it is interesting. All right, so now, next we have, so that's good. Did you work out this one here?
I started to, but I'm just a little confused. I wasn't here.
Did anybody work out?
I did it. I don't know if it's right.
You did? What, Aaron, tell me what you got. Let's see what you got. We'll see if we can,
You want the line?
yeah, go
For the line
ahead.
I got just y equals 4.
Y equals 4.
Yeah.
So Aaron got y equals 4. So you got a slope of 0 is what you're saying.
I don't know
Yeah.
if that's right, but
Well, we can work this out. If we take low is equal to x minus 1, d low is equal to 1, high is equal to x squared, and d high is equal to 2x. And so we go ahead and work that out. F prime of x is equal to low d high minus high d low, because that's high and d low is 1, all over we have x minus 1 squared. If we plug in f prime of 2, we get 2 minus 1, which is 1 times 2. Well, actually it's going to be 2 times 2, right? 2 times 2 minus, that's going to be 1, minus 2 squared. And right here you have over 1, because 1 squared. Yeah, and this is going to zero out here. So you're going to get f prime of 2 is equal to 0. So therefore, you'd have your slope is 0. So you're going to get, in slope interval form, you get y minus 4 equals 0 times x minus 2. And so you're going to get y equals 4 is going to be your answer on that. Okay?
Okay, that makes sense. it makes sense, like,
Yeah,
doing it, I just need a little help.
yeah, that's right, that's right. That's part of the reason we're doing the exercise on these. Okay, and then lastly, I want you to look at 28, right? Did you do that one yet?
That looks like fun.
Yay.
Which is kind of a combination in a way, because here you have your, and you could do things different way. You could simplify out. In fact, this is what I would do, I think. I would just multiply these numerators together.
That's what I was thinking.
So I get 4x squared, and then you'd get 12x plus 1x, so plus 13x, plus 3, all over x plus 1. So that's what I would do. Is that what you got for the multiplying out of these things?
That's what
That's what you got? Does that look right? There's something that's, yeah, that's going to be 12x, and that's 1x, so that's 13x. Yeah, I think that's good. Hannah, have you finished this one?
Yeah, there's one more I haven't saved.
Do you need some more contact solution?
No, it's fine.
More contact solution, there it is. All right.
Oh, the bubble line. Now here you got a situation where, I don't know if you want to plug in -1/2 right off the bat, or if you want to simplify first. Because it's just not as going to be easy as putting 1 or 2 in here. So, I mean, you can work it different ways, because you're going to have a lot of like terms being combined in this thing. So how did anybody do it? Did you combine the like terms first, or? I'll get 8x squared plus 8x plus 13x plus 13 minus 4x squared minus 13x minus 3 so all over x minus 1 squared. So here we get 4x squared, and then you'd have 8x plus 13x minus 13x, is that right? So you have plus 8x, and then you have plus 13 minus 3, that looks like plus 10, all over x minus 1 squared. So if you go here and have y prime of negative 1/2, negative 1/2 squared isn't 1/2 squared like 1/4? So you'll have 4 times 1/4, because that would be 1/4. And then you'd have 8 times negative 1/2. So that's going to be like negative 4 plus 10 all over negative 1/2 minus 1. So you get negative 3/2 squared. So what is that going to be? 1 minus 4 plus 10. Isn't that right? 1 minus 4, that's negative 3, plus 10, that's 7, isn't it? So you get 7 over, that's going to be 9/4, and then that's going to be the same as 7.
Isn't x plus 1 squared on the bottom?
Oh yeah, it's x plus 1. That's going to make your life a little easier. Yeah, it's going to be x plus 1. I mistranscribed here. Yeah, so it's going to be 1/2. That's going to be 1/2 squared, which is going to be 1/4 and not 9/4. So you have 7 divided by 1/4, I think, which should be 28. Is that right? I don't know how right that is. Is that right? That's what you got, Gavin? Did you try using the calculator too? You got the calculator? Yeah, but that's, okay, the arithmetic. And you see, a lot of times you get to these, and it's sort of like the concept, the mechanics of doing it, I mean, of how to do it, is not, the concept is not hard, but the arithmetic could get a little bit like tedious over time. It's like my little mistake that Aaron caught. I just rewrote this thing down here as x minus 1. Just carried. I would have got a wrong answer. So I'm going to go ahead and do that. Just test the calculator. So we go to math 8, excuse me. So x plus, what was that? I don't remember what this is. It's x plus 3 over x plus 1. Over x plus 1. And I'm going to come up here and multiply by, what is that? 4x plus 1. And then go here and put x equals like negative 1/2. Yeah. And again, it's that same little rounding thing, but that's right. So now we can write our equation, which is y plus 5 equals 28, x plus 1/2. Is that what you got for that? Pretty straightforward. Okay. Let's go on to differentiability. Differentiability. Horizontal tangent, I don't think we've talked about that much. But what you do is you set your derivative equal to 0. Take your first derivative, set it equal to 0. That's where you have a horizontal tangent line. And we're gonna do that later. These ones here, this one here is a scavenger hunt of things to check things out. Parallel and perpendicular, we haven't got over that yet.
So we're back to differentiability, so I'm gonna leave it there. So this sort of review, I hope, of product rule and quotient rule.